Hi everyone, welcome to Huawei Cloud Tech Talk. My name is Danny Chen. I'm a Senior Principal Architect at Huawei Cloud. In the past issue, we focused on GaussDB storage engine and high performance through parallelism. This issue will focus on GaussDB HTAP feature. In the fast-changing world, more ad hoc queries are performed on LTP systems to reduce data movement and serve on-demand business requirements. For example, anti-money laundering in the finance sector, it does real-time analysis and data governance. Another example, in e-commerce, the system makes real-time recommendation based on user profile and changing user behavior. This also requires the database to provide the capability of real-time analysis. Database designs are fast-changing. The first approach to address the HTAP scenario was using a row storage and a distributed column storage, which means there are two engines, one row engine based on row storage, another column engine based on column storage. This will isolate the system and the resource well. However, it doesn't provide real-time data freshness. An updated system comes with a main row store and the row storage on disk. On top of that, it provides a in-memory column store. However, it still appears to be two separate engines from end user's point of view. The application has to be aware of the different engine and send the request to the different system. However, it does solve the data freshness issue. GaussDB, on top of this previous approach, provide 100% of data freshness, performance improvement, transparent system to end user. Also, it isolates the resources from two different types of workload. How does GaussDB achieve that? Let's take a deep look. GaussDB uses multiple components to address the issue. First is the mixed load optimizer. It's a hybrid load routing system, and it's lightweight, make a lifetime decision using AI-based technologies, so that end user, the application, does not need to distinguish between different paths or different engines. Second, it has the in-memory column store, which is built at the time when database is loaded up. So it takes over the data from row engine and build this in-memory only column store. While changes goes to row engine, it will have a delta storage component, take the new changes from row engine and incrementally make changes to the column store. So the column store will be periodically bring up to time. Third, we have the resource management, which will manage the CPU and memory for the two types of workload, making sure the live transaction system is not affected by the running heavy load AP type of workload. In action, let's take a look at how the mixed load optimizer works. We still open up some control knobs to end user because they know the workload. So the user has the option to instruct the system to whether this workload goes to row engine or column engine. But before that, the query engine will take a look at the query itself and look at whether it makes changes to the data. So read-write type of workload will always go to the row engine. But if it's a read-only workload, after we take the instruction from end user, use this rule-based decision, we have the AI-based selection system. It will look at the query and it will generate a confidence level. If the system decides that it has high confidence of AP type of workload, it will try to route the access to the column path and run it through column engine. If it has a high confidence of transaction type of workload, it will route this access to the row store and eventually be executed in the row engine. If it can't give a high confidence level, our cost-based decision will kick in. It will choose the optimal path based on the cost-based decision, and it might use the column engine or the row engine to execute it. That's how GaussDB make this whole decision transparent to end user. To summarize, GaussDB's HTAP system intended to lift the decision from end user, make the application much easier to to use a single engine. It also provides high performance through the running path, smartly choosing different engine, also provide 100% of data freshness. Don't forget about the smart resource management system between the TP and the AP workload, making sure that GaussDB is always running at the best performance. Thank you.